Brooks Davis from the FreeBSD or FreeBSD Foundation, right? Project. And he's going to talk about LLVM, integrating LLVM into FreeBSD.
Yeah, I guess I'll go ahead and hold it. Okay, thank you. So yeah, I'm here today to talk about our work integrating LLVM into FreeBSD, mostly Clang, but in the future more LLVM bits. Myself, I'm on the FreeBSD core team, and I'm sort of the semi-self-appointed Toolschain lead, so I run Toolschain summits and get people to show up. And I also maintain the port in our package collection of LLVM and Clang. The key work that's been done on integration has mostly been done by other people, but I'm sort of there in the middle. What I'm going to talk about today is where we are, sort of how we got to where we are today, what we still need to do, what help we need to do that, and then some ideas about future work and perhaps deeper integration of LLVM into our source tree. So I'm going to start back in 2006, about 5 years ago. At that time, we had a GNU toolchain in the base, reasonably current, and you know, GCC, binutils, GDB. That's all basically what's still there today as the default compiler. One interesting thing that did happen in 2006 is that we, as part of a project called HWPMC, which looked at hardware performance counters and made them accessible, a project was started called BSD ELF tools, which is basically, the goal is to replace binutils with new pieces of code. This came out of the fact that to do all the performance counter work, they needed most of a libelf. And so they started doing other things. The first big piece of that got integrated into our tree is an AR implementation, which was implemented in libarchive. So our tar speaks AR. That was actually in 2007. But that project is tooling along, and it actually has most of the pieces done other than a linker and an assembler. But pretty much everything else, your NM, your objdump, strings, and the like, is there, and some of those are integrated, some of those are not. So 2007, GPL v3 came along after many years. We were, as a BSD licensed operating system project, this kind of put us in a quandary. We knew that once GPL v3 was out, all the tool chains issued a new release for the sole purpose of changing the license within the next month. And for us, that was a big problem. We didn't actually make our formal policy declaration as to what we were doing with v3 immediately, but we did say you can't put it in until we decide. It did take us a couple months, and we basically at that point said, you know, a lot of our customers, a lot of the people who consume FreeBSD cannot accept v3 in-house. Some of them have had changes in policy over time, but a number of them still have a fairly strictly enforced, if it's GPL v3, it better not come in the door policy. So that was a big deal. And that led to a toolchain freeze, effectively. We had a few minor revisions to GCC that we could pull in, a few GDB bits. In some cases, we've been able to get authors of patches to give us specific license to use them under GPL v2. But essentially, we were frozen. And the issue for us was, you know, we knew we needed another solution, but we're operating system developers. We don't write compilers. We don't know what we're doing when it comes to that. So we were sort of stuck. So we dithered about policy for a while, and then we finally said no v3 in the tree. And then we said, okay, well, now what? Some of the other projects, OpenBSD went off and started working on PCC, but we kind of felt we wanted a performant compiler. So we didn't really feel that was going to be a real option for us. Fortunately, Clang was announced, and the initial code was obviously not something we could import into the base. It wasn't self-hosting by any means, and it wasn't a C++ compiler at all. But that gave us some hope. 2008, 2009, lots of things happened in the Clang and LLVM world, lots of progress. I'm not going to talk about that, but lots of good stuff went on. We made some minor updates and fixes to our tool chain, but essentially it just sort of aged. For x86 and AMD64, it hasn't been a huge problem, although new Intel instruction sets have had minor issues. It's been kind of a pain to get those added. But it's been a bigger problem in the embedded side, where there's lots of MIPS and ARM processors coming out all the time, and our consumers want to use them and want to use features on them. So that's been a big deal. We also, during that time, we invited Chris Latner to come and speak at BSDCan. That generated a fair bit more interest in the whole process, in the possibility of using Clang, and got people thinking about, this is potentially a viable alternative. 2007, Clang became self-hosted, and so that at that point we said, okay, now we've got something that's a way forward. We know we have a performant compiler here, and this is something we could consider importing. So some developers started working sort of in the background on getting the compiler integrated into the system. In May, we held a BSD Toolschain summit at BSDCan. We had people from Apple in the Unix tools group. We had customers like NetApp and Juniper, a bunch of developers, people from the FreeBSD Foundation. We talked about, what's our way forward? And our proposed way forward was that we would, over time, replace GCC and all the other attendant bits of the tool chain. And with GCC itself, we were looking to replace it with Clang. Now, an interesting bit of timing that happened when we were working on this was that we were talking about all of our various gaps, and things like the linker came up, things like a C++ library came up, and of course a debugger. We talked about a number of options there. The actually most running one that we had at the moment was one that another developer of the project had written because he was bored in D. So we considered briefly giving him the Palstra Award for obscure language choice after our developer who developed our entire source distribution system in Modula 3. But for a while, we seriously considered it. The fact that there is an LLVM front end was promising, but not really the direction we wanted to go in. The interesting thing, though, as we were talking about all this, the next day after the Developer Summit, Apple announced libc++ as a project and open sourced that. Obviously, it's taken a while to get to the point that that's something we could use, but that was a fortuitous bit of timing. At the point of the summit, we had patches available to build Clang and LLVM with the base system, and shortly thereafter, in June, we did an initial import. So we brought those together. Our Buildworld, our process for building the entire operating system, which is what we call Buildworld, at that point built both Clang and GCC, and with the right configuration flags, you could then bootstrap with Clang. Not everything worked. We had to have a bunch of options in the code to say, don't build this because it doesn't work for some reason. Mostly that was because the code was bad. But in other cases, the thing that took us the longest and took until September of that year was that one of the initial bootstrap codes, what we call boot 2, is size limited to 8K. It took quite a while to figure out both fixing LLVM size issues in terms of code generation, as well as cleaning up the assembly and removing a few pieces of functionality that no one used to really get that down to the size that we could actually build everything. That did happen in September, and at that point we were fully self-hosted with Clang as an optional compiler. One interesting side effect of all that work on boot 2 is actually that we've been able to remove, I think, a half dozen or so strange compiler options that we were passing to GCC to try to get the size down, because we actually now have a much cleaner piece of assembly code. So that was a nice side effect of all this work. So also in 2011, we had a mini BSD licensed toolchain summit at FOSDEM. We talked to a number of people there. FreeBSD had not been doing any real work on towards getting libc++ into the sort of shape we needed to get it into the base. But people there were really encouraging about the possibility of getting that done using a combination of libunwind and some other code bases. And in fact, I think some of the discussion there, as well as some other fortuitous events, led us to the fact that we now have libc++ ported. David Chinstall is now a FreeBSD committer as of last week, and will be importing it into the tree. In his tests, it now actually passes slightly more tests than the Apple one on Darwin, which is interesting. And in most cases, we're both failing the same tests because of lack of atomics in some places in LLVM's code gen. So this actually was a combination of adding some extra code. It was also a case of getting PathScale to relicense us their libsup C++ code, which is a combination of libunwind and some other bits. But with this, we're pretty close, and I'm guessing that we're going to see libc++ in our base in FreeBSD, in head, which is going to be FreeBSD 10 within the next month or two. There's also work in progress now on an LLDB port. There's a couple of people working on it. Mark Peak, who is in the back, has been doing some work, and also Kip Macy has been doing some work. So we're making some progress there, and so that's good. I think the first step there is we're going to get it to the point that it's building, get as many patches into the LLVM base tree, and then we'll get the code into our ports collection so people can start building and testing. Once that seems to be stable, we can start thinking about the issues of how do we bring it in, because unlike, say, Mac OS, we're probably not going to want to fight the battle to bring Python into the system. We evicted Perl quite a while back. Bringing in a new scripting language is going to be a whole political disaster. So we need a way to integrate where we can allow people to have Python and take advantage of it if it's there, and not use it if it isn't. So that's sort of the timeline to where we are. Now I'm going to talk a little bit about status of the specific things going on. In FreeBSD 9, which is in the final stages of the release process, I believe, I've been traveling too much, not paying attention, but I believe we're in the release candidate 2 stage. We rarely get more than 3 of them, so we're probably within a month of release. So right now, GCC remains default. I'd been kind of hoping that we could get i386 and AMD 64 switched, but we really ran out of time, so we're not doing that. We're going to have Clang roughly 3.0 in the base. We have an import a couple weeks ago after the branch, and I'm not sure, they may manage to do one more merge. Since it's not in the bootstrapping path by default, we can be pretty aggressive about importing features even late in the release process, as long as it keeps building. And we've managed to replace much of libgcc. There's the libgcc static object. It has mostly been replaced by compiler RT. Some of the dynamic stuff is not replaced and yet, because we need to import more bits of libunwind and implement a few things. There's also some odd cases where the contents of libgcc vary by architecture, and we found on, I believe, Spark and ARM that they assume some GCC built-ins which are implemented in libgcc in the GCC world. So we've got some work to do there, but we're in pretty good shape. And some BSD-ELF tools, I know AR and I think 1 or 2 others, are in the base system. So we're making progress on getting bin utils replaced. Now, some work's in progress. These are things we need to do for 10 or things we need to do in general. Our hope for FreeBSD 10 at this point, which is probably 18 to 24 months out, is that we could actually be GPL free. I think we have a pretty good chance, but it's going to take some real work. And some stars are going to have to align and whatnot, but I think it's actually possible. The one that's coming up right now, it's being worked on, is libc++. We've already been making changes to libc and making headers more C++ compatible to get that in. So we're doing well there. We have that LLDB port I talked about. that's worked on. And there are some patches available to switch to make the compiler in the ports collection switchable. Right now, the whole system assumes, and many ports incorrectly assume, that capital CC equals user bin CC. And similarly, the CXX variable is the base C compiler. We need to change that for a number of reasons, but in this case, we know that some consumers are going to be perfectly happy if user bin CC becomes Clang and their ports continue to build, and as long as that works, great. But right now, we're building only a little over half of the ports collection with Clang, and then we bump into some large dependency block, and there's an iterative cycle to fix things. So we need to make that switchable. There are patches out there. We're sort of stuck because 9's holding everything up, so we can't make big rototilling changes to anything. But that's in progress. We also have some other general to-dos. We need to finish the lib GCC replacement, and I need to get the people who actually know what they're doing about that to write up what we need, and so we can have some more help there. We need better external toolchain support for our build system. This is both so that architectures that LLVM is not going to support, like IA64, and other less solid architectures like Spark64 can still be supported in our build system. And because one of the realities of the embedded world is that you often, or at least my friends in the embedded space tell me, is that you often buy some system on chip and it comes with a copy of GCC where they've hacked it up to compile to whatever ARM or MIPS ISA the chip supports, and they've probably broken every other system of that platform in the process. So we've got to deal with this stuff. It's been a big problem, and the fact that we're moving to Clang is going to be is a helpful forcing function there. The next thing, right now, you can change what base compiler which compiler you use in the Bootstrap by setting, I think, 4 or 5 variables. That's too many. It needs to be 1. We also need the ability to easily switch at compile time which compiler is going to be installed as user bin CC and user bin C++. So we need to get that cleaned up. Small matter of programming, should be easy. And we need to be able to set that default on a per architecture basis, because right now we could easily switch i386 and AMD64 to using Clang, but we couldn't switch ARM, for instance. And we just need to generally clean up our cross-build support and get it all integrated with the Clang driver. Following all this stuff, the next big thing, and what we're going to do fairly soon after 9 comes out, is we want to actually switch the default base system compiler. And when I was talking to the people who maintain our ports collection, they were actually pretty open to the idea of switching the default ports compiler, despite the fact that adding Clang right now blocks about 9,000 builds. So they seem to think that all the issues were pretty easy to solve, and if we just changed the default, they'd get fixed pretty fast. So that's another big thing we need to do. We need to also likewise pull in the rest of the BSD ELF tools. The developers consider them complete, but they're not really tested. And there's not really a much better way to test them than throw them in and build all of the ports collection. Building 22,000 packages should be fairly helpful, especially once we start running them. And then really it's a matter of testing. That plus all the other things I talked about are the big things that we need to get our whole toolchain swapped out in 10. There are a few gaps remaining. The first one obviously is the linker. I'll be attending the linker session earlier. We actually had a brainstorming session at EuroBSDCon earlier this year, coming up with a feature set. I think our sort of random wag of how much it was, we probably had 3 years of work to get everything done, but I think a full linker is a lot closer than that, especially because we have a couple of projects here working on them. Next thing is ARM support. There's obviously good, strong ARM support in LLVM, but FreeBSD is using a somewhat older ABI, so we need to get that resolved one way or another. Similarly, MIPS and MIPS64 support is there, but we need to do some more testing, and it needs to be probably a little more robust. And we need to do something about Spark64. I think the reality is they're not going to be self-hosting, but it's somewhat of a gap for us, and if someone was bored, maybe they could fix it for us. The other one is we do have a number of users who are using gcov, and as far as I can tell, there's no convenient replacement at this point. We need something in that area. We need some sort of coverage, code coverage metrics available. I think these users will likely continue to use GCC toolchains, which is fine, but that seems to be a gap at this point. So, I've talked about how great the integration's gone and how we're making progress. We have had some acceptance issues. There's a lot of general inertia. For one thing, a lot of people have put a lot of time and money into their GCC toolchains. Some of it, people just say, if it's not broke, don't fix it. And from their perspective, it's not broken. Of course, it is an increasingly old toolchain. We're talking about tools from mostly 2006. So half a decade old at this point. Lots of features aren't implemented, so it's kind of a problem there. A number of organizations, as I said, have a lot of investment in their GCC toolchain, things like gcov. So that's an issue. There's architectures like ARM and MIPS that for us are not as strong as we'd like. So but I think that's going to come along and improve over time. I think just the fact that we're signaling that this is the direction we're going is going to help encourage silicon vendors to implement new features. So there are some we have heard expressions of quality concerns. I don't believe that there are any specific problems that they're referring to, but it is something that we've heard. Mostly it's not so much that people think that the code is bad, code gen is bad, or that dwarf information is bad. It's just that they don't know one way or another what it's like, and so change is scary. So that's just something we're facing. And some other people are saying, well, what's the benefit? Couldn't we just go, with the latest GCC? I did have some pretty good luck pointing people to the posts from Google recently on the mailing lists about moving Chrome, and I think those reassured some people. But it's not going to be the case that everyone's going to benefit from this directly. And some people aren't sure. It's a relatively young community, so they just don't know what the future holds. I think the fact that we have this great turnout here should be reassuring to most of them, though. So one question that we're asking ourselves and trying to get a handle on is, are we going to allow Clang and LLVM specific features once Clang is our default compiler? We decided that for 9, that the answer would be no. Partially because we didn't have any, but also partially because there was enough work to do without having to deal with the fact that we'd have part of the code base that couldn't compile. So we're still trying to get our hands around it, but the big question is, if we do it, when, and what sort of features. For when, I think that our current view, and I haven't heard any real objections from the community at this point, is that we would accept optional features in FreeBSD 10. And I'll talk about one of those features in the next slide. So features could either be something that you didn't have to use, a driver or a module that was not necessary, or some sort of partial build, something that generated better error output or better analysis. And that would be okay. The other thing would be anything that you could compile out with a standard C compiler and a standard preprocessor. There's also the question in the farther future, certainly not in 10, or I think almost certainly not in 10, possibly in FreeBSD 11, should we consider the possibility of non-optional features? I think at this point there would be an incredible amount of resistance to that, but if there were non-optional language features that could be dealt with through source-to-source translation, that might be a possibility. I think that would really raise the bar because you'd have to redo all the build system, but I think it's conceivable that we could get there. So I'm going to talk now about three potential projects. This one's actually a concrete thing. It was presented in a poster at the European LLVM developers meeting, but it's a project that's at the University of Cambridge, SRI, and Google to implement temporal logic assertions. The idea is that you represent things that have to be true temporally. For instance, that if this is true now, then you can assert that this must be then that must be true in the future, or that something must have been true in the past. So that's the simple temporal logic. There's also the concept of automata, where you can describe a state machine and you can assert that the state machine holds throughout a computation. And this is something that's verified in runtime. They're using Clang to insert instrumentation into the system, and their whole design is that if you just set the macros right, you can just compile it out with CPP. But if it's there, you can do a lot of model checking and do it at runtime. So all these assertions that you defined in this case are defined at runtime, and only experienced paths are tested, because this is an operating code. And then when things fail, it's a classic assertion. So you have your option. You can either panic, which would be a traditional behavior of a kernel assert. You could alternatively issue a stack trace at that point, or you can generate a dtrace event, and then you can pretty much do anything from there. There's work ongoing at Google to add code to OpenSSL to verify that the security model is being followed, so that to verify that consumers are using OpenSSL correctly. There's some work in FreeBSD to verify portions of the network stack, and look at verify that your TCP state machine is actually being followed. And so this is pre-publication work at the University of Cambridge, but it looks pretty interesting so far. Another idea we've discussed is the idea of implementing a JIT for the Berkeley packet filter, or BPF. There's an existing JIT in FreeBSD derived from the one in WinPCAP, but it's a very, very simple JIT. It just looks at the bytecode in the Berkeley packet filter and emits assembly into a buffer, and then or emits machine code into a buffer, and then runs it. There's no optimization on it, and it's hard coded. And right now, you have to write one for every architecture. So there happens to be one for i386 and AMD 64, and I believe there's one out of tree for MIPS. But that's the problem for other platforms. And of course, if you got new instructions that would be useful in this case, that would be useful, you would have to modify the kernel module. So one thing we've been throwing around is the idea of having a daemon in user space that would allow us to pass up to compile the packet filter rules into IR, pass them into user space to be compiled into machine code, and then return down. The reason for the daemon model is, of course, that we don't have C++ in our kernel, and you would need an awful lot of C++ to get LLVM working in your kernel. And another project that some people are contemplating is looking at firewalls. It's worth observing that firewalls are all domain-specific. Firewall rule sets are domain-specific languages. They generally are converted into bytecode and interpreted in the kernel. And so, why couldn't we speed them up? One of the problems that additionally that FreeBSD has had is that we have too many firewalls. We're at the moment down to 3, but we'd really like to bring in the syntax from the later versions of the PF packet filter, but we don't want to break our users, so that would involve a 4th packet filter if we brought that in. And then there's other things like NetBSD's NPF. So there's an issue there. So one one developer is proposing doing some research on possibly something with the one firewall to end the ball, and try to get us maybe someday as an aspirational goal, get us down to one firewall in the kernel. So that's really where we are on these ideas. I think overall, we're seeing that the FreeBSD and LLVM are a really powerful combination. Even just with the Clang compiler, we're getting a lot of cleanup benefits in the code base. We're having some minor issues in terms of compiling the system with warnings being errors, mostly because of the GCC code base. That's the majority of errors at this point. But mostly because it's just ancient code. But we're really, I think, pretty happy with where we are, and I think we've got a pretty bright future here. So with that, I'd be happy to take any questions. So the issue with Python is simply that we've fought battles about what scripting language should be in the base, and it's a messy political process. And the problem with bringing any modern scripting language into the base system is that with it comes a huge standard library. Perl, for instance, pulls in 60 megabytes of code, and so we don't really want to add that to our code base. Our view is that with LLDB and its use of Python, my understanding is that LLDB's use of Python is mostly for optional features as well as for scripting. So we'd like to integrate LLDB in a way that if the user installs Python, they can take advantage of that. And if they don't install Python, they still have a debugger. So it's not that we hate Python. It's just that some people also love Ruby, and some people like Perl, and Jordan still likes Tickle, so we're at this point, no one's really willing to fight what scripting language should be in the base. If it were Lua, that might actually get through because it's so small, but that's really the only issue. Yes.
So you mentioned that the version of LLVM you have is slightly past 3.0. Who makes the call for what the actual LLVM code you bring in? Who knows what patches to pull?
So what I believe people are doing at this point is they're just importing snapshots of a particular revision from the LLVM repository. We're actually just slightly post-branch and obviously pre-release. And so there's a couple of developers who are working on the import, and they mostly decide to do it when it seems like a good idea and when they aren't seeing signs of a lot of upcoming churn. So that they're in a situation where they think they could safely pull stuff. Longer term, we'll probably get to a point, certainly if we get to the point where we're actually providing any of the library interfaces, which right now we don't. Clang is a really giant binary right now. If we were providing those library interfaces, then we would probably have to stick to a particular LLVM release. But right now, we don't see any big benefit to that. We'd rather be taking advantage of the improvements in the LLVM code base and sort of sacrifice some of the ABI and API stability for that. I think in 10, once it's the base compiler, we're probably going to have to commit to an LLVM. I think there's a good chance we'll have to commit to an LLVM release. Although it may be that we'll change our mind and have a policy where we bring in releases over time. Something we're going to have to think about going forward. As long as it's simply the compiler, it's probably okay if things change. We might, even if we provided libraries, end up renaming them though, so they didn't conflict. We've done that before.
So you mentioned the issue of quality concerns with members of the community. Clearly, when you move to these tool changes, it's a huge change.
Yeah.
Right? So as part of that shift, what kind of quality the measurement work would be
We're not really doing anything formal. The most specific concern that I've heard is just concerns about whether dwarf generation is sufficiently similar to GCC that GDB will be happy. And that seems like it should be okay, but you know, I think in most cases the quality concerns are the concerns that we always get when we move from one GCC to another, except more so because it's an entirely unfamiliar code base. And so people, you know, sort of know what's screwed up and what's not right now.
You mentioned certain issues with ARM platform as well.
Uh-huh.
What are the big stumbling blocks and how can members of the community help?
I'm not the best person to ask that, but my understanding is that we're using an older ABI and a different ABI specifically than Apple. And so I'm not sure what needs to change to generate the right ABI output at this point. Yes.
You were mentioning dumping optional or non-optional features inside the code base, but you had also mentioned previously that you have certain architectures where you don't have anything that is going to build on Clang. You're picking up custom GCC
Yeah.
things like that. So presumably that would be a blocker to non-optional.
I think there's no current path to non-optional language features, but you certainly could use a source-to-source translation if there were something that were a big enough benefit. One of the things, though, that we've observed in the past is that there are a lot of other tools out there, tools like Flexulent or Coverity, and if you get too far away from C, they don't work anymore. So, you know, there's a lot of trade-offs there as well. In terms of what you might or might not want to do. So the barrier for entry is really high if you're going to change C.
Do you have any performance metrics between GCC and LLVM?
On the base system, or
Or running Buildworld?
I don't know that we've been measuring build worlds. Somebody ran one of the general system call benchmarks quite a while back. We need to do it again, but the general trend there was that there was a lot of variance between the two, but it was pretty random which compiler won, and the results were stable, but there was a fair bit of variation. So there's undoubtedly going to be some tuning to be done, but one of the things the project lacks at the moment is continuous integration of performance measurement. So something we need to work on in general. Okay. Thank you, everyone.